And so, a quick summary of the 4 solution methods for relative velocity. We start off with the table method. The table method, we just kind of churned out the numbers based on the simplest relationships between the velocity of car 1 and car 2, cranked them out and tried to narrow down the answer. The graphical method used our knowledge of d versus t graphs and slopes to find the intersection points. And we invoked Logger Pro to help us with that because it's got some tools that can do this very accurately once we throw in the right equations. It's great. Harder to do on paper, but you could do it with graph paper as well. The algebraic method, we modeled the motion from the d versus t graph. We got the equations that describe the motion of car 1 and car 2 and also the head start and just solved. Did all the algebra. We used SADMEP and t was solved for. Then we plugged our value of t into the equations to get our displacement. Very solid method. And then the relative velocity method is another way of thinking of what happens. It's a method where we look at the difference between the 2 cars. We know they're both moving relative to the ground, but they're moving relative to each other. So in one case, we have position of one car. It looks like it's moving towards one another at the difference in velocities between the 2. And so it gives us kind of another way of thinking about how one car approaches the other in reference to each other. And that can be helpful too. And again, physics is strengthened by representing the information and going about it in different ways. We get a stronger feel and a better one when we could represent the situation through different means. That's physics. All right. And this is Morad.
Out.